Okay, so here's a solutions video from 3 of the problems in OpenStax in 8.1, linear momentum and force. So we'll be doing problems number 2, 3, and 4 out of the book. So problem number 2, it says, what is the mass of a large ship that has a momentum of 1.6 times 10 to the 9th when the ship is moving at a speed of 48 kilometers per hour? So this problem, let's see, let's write down what they tell us. So we have a ship, it's moving, it has a momentum. So the momentum is equal to 1.60 times 10 to the 9th kilogram meters per second. And then it's moving at with a velocity or speed of 48.0 kilometers per hour. And I can see right away this is a problem. Let's go ahead and convert that. Do that work over here. So 48 kilometers per 1 hour. We need to have everything in meters per second. So kilometers is up top, so I write it down below. I want to go from kilometers to meters. And there's 1,000 meters in 1 kilometer. So those will cancel, giving me meters, and then I need to convert hours. Hours is down below, so let's write it up top. And we can go into minutes. So there's 60 minutes in 1 hour, and then that cancels the hour, but we need to take minutes to seconds. So we'll get minutes and seconds. So 1 minute is 60 seconds. So that would be, let me calculate it. Okay, so we get about 13.3 meters per second. So we'll go ahead and say that this is equal to 13.3 meters per second. And then what we want to know is the mass. So what's the mass equal to? So for this problem, it looks like we'll just be using the definition of momentum. So momentum is equal to the mass times the velocity. So if I want to know the mass, I just move v over. So I'll get mass is equal to momentum divided by velocity. So that would be the momentum, 1.60 times 10 to the 9th, over the velocity, 13.3 meters per second. That's kilogram meters per second. And if we divide that, we'll get 1.2 times 10 to the 8th kilograms. It's kilograms because we're talking about mass. And that's part A. Part B, we want to compare the momentum to the momentum of a 1,100 kilogram shell fired at a speed of 1,200 meters per second. So one way of comparing is to just divide and get a ratio. So B, we know the momentum of the ship. It's 1.6 times 10 to the 9th. And what we want to find is the momentum of the artillery shell. So that would be, that's what we want. Okay. So what we're going to do is we're going to compare the ship's momentum, so the momentum of the ship divided by the momentum of the artillery shell. We know what this value is, so we can just plug that in, 1.6 times 10 to the 9th. And we're going to divide that. The momentum is the mass times the velocity. So we'll substitute those values in. So the mass of this shell is 1,100 kilograms times the velocity, which is 1,200. So we'll put this into a calculator. And we get 1212. So about 1,200 times more. So that's just finding a ratio. All right, let's try number 3. Okay, so for this one, we're just doing part A. So it says, at what speed would a airplane have to fly to have the same momentum of the ship from the problem 2, the one we just did? And so we want to know the velocity of the plane if the momentum of the plane equals the momentum of the ship. And we're given the momentum of the ship, so that we know. So we can go ahead and start substituting. So the momentum of the plane would be the mass of the plane times the velocity of the plane. We want that equal to the momentum of the ship. So we're solving for the velocity, so we'll just divide. So the velocity of the plane would be the momentum of the ship divided by the mass of the plane. We can substitute in those values. So the momentum of the ship was 1.6 times 10 to the 9th, and then we divide that by the mass of the plane, which is 2 times 10 to the 4th. And calculating that, we get 8 times 10 to the 4th meters per second. So that's a crazy big number. Couldn't do it. The plane couldn't go this fast. But there you go. There's the answer. All right, finally, number 4. Okay, so this problem has 2 parts. What's the momentum of a garbage truck? They give you the mass and the velocity, and then what's the speed? What speed would a trash can have the same momentum? So it's kind of a combination of the previous 2 problems. And so we're given the mass of the truck, T, 1.2 times 10 to the 4th kilograms. Moving at 10 of velocity of the truck would be 10 meters per second. So for part A. So the momentum of the truck would just be the mass of the truck times the velocity of the truck. So we just substitute in our numbers. 1.2 times 10 to the 4th times 10. And that will give us 1.2 sorry. Yeah, 1.2 should be just 1.2 times 10 to the 5th. Let me just double check. Just 10 to the 4th. Yeah, 1.2 times 10 to the 5th kilogram meters per second. So that's the momentum of the garbage truck. Part B. Part B says a garbage can. So if the mass of a garbage can is 8 kilograms, how fast does the garbage can have to travel such that it has the same velocity? So that means, the same momentum. So we want the momentum of the garbage can to be equal to the momentum of the truck. And we have the momentum of the truck, so we're working on this side. So the mass of the garbage truck times its velocity, garbage can, is equal to the momentum of the truck. And we want to know the velocity, so we'll just divide that over. So we get 1.2 times 10 to the 4th, 10 to the 5th, divided by the mass, 8. Again, we're going to get a really big number here, so divide by 8. 15,000 meters per second. And so those are the practice problems for 8.1.